So in this chapter of your introduction of irrigation engineering, we already studied about the advantages and disadvantages of irrigation. Now we are going to study the type of irrigation. Okay. So type of irrigation, right? Type of irrigation. Okay. After that we will study method of irrigation also. Okay. So what is the difference in type and methods? So in methods we will see how water gets distributed over the field, and in type we will see by the means of water, by means of ways how we can supply the water to the field. Okay. So if I say this will be the irrigation, so I can say that my irrigation can be divided into two types. So what are they? So irrigation is divided into, mainly broadly I can classify this into two types. What are they? Okay. So the first type will be surface irrigation, and second will be my subsurface irrigation. Okay. So first will be I can call that is as surface irrigation. Okay. So what is surface irrigation? By the name itself, surface irrigation, when we'll irrigate the field in the surface. Okay, when we'll irrigate the field by surface means, okay, by surface means, by means on the surface of the soil we are supplying the water on the surface of the soil. If we are supplying the water on the surface of the soil, that is called surface irrigation, and if I supply the water under the surface, that is called a subsurface irrigation. Okay. So these are two type of irrigation. No need of definition for that. So after this I can say that there will be two type of surface irrigations. Okay, there will be two types of surface irrigation. So what are they? Okay, so they are, first is flow irrigation. First will be flow irrigation. Okay, means on the surface also you can supply the water with the help of gravity or with the help of pump. Okay, so if I supply the water with the help of gravity, that will known as flow irrigation, and if I supply the water with the help of pump, that I can call it as lift irrigation. Okay, that I can call it as lift irrigation. Okay, so here I can write supplied by pumps, with the help of pumps. Okay, so I can say in flow irrigation what happens? In flow irrigation my water is available at the higher head, so that I can supply the water in the lower parts with the help of gravity. Okay, so water available at higher head, in this water available at higher head. Okay, at higher head, please write higher head. Okay, and so that we can easily supply the water with the help of pump, with the help of gravity. But here water available at lower head. Okay, lower head. Okay, so you can lift mainly in this water is supplied with the help of wells. Okay, with the help of wells we'll use pump and then we'll supply the water. Okay, similarly here also we have two types of subsurface irrigation. Okay, so we have two types of subsurface irrigation. So what are they? One is natural, will be natural, and another will be artificial. Okay, one will be natural. So we have a natural subsurface irrigation, and we have a artificial subsurface irrigation. Okay, So what is the difference between natural and artificial? Okay, so we'll see what is the difference between your natural and artificial subsurface irrigation. In natural, we have a higher water table, or a local water table is at a lower depth. Okay, so that can be easily supply the water with the capillary to the root of the plant. Okay, and in artificial, what happens, we laid the perforated pipelines under the soil. Okay, so we'll also see this natural and artificial. So I hope this is clear, what will be the flow irrigation and what will be the lift irrigation. Okay, now I am going to discuss that there will be two type of flow irrigation. Okay, there will be two type of flow irrigations. What are they? Okay, so we have a perennial irrigation. In flow, we have a perennial, perennial irrigation. Okay, we have a perennial irrigation, and next is your inundation irrigation. Okay, inundation irrigation. Okay, so in flow also we have two type, perennial and inundation. Okay, so what happens in perennial? So in perennial, we have a constant and continuous supply of the water throughout the crop period. Okay, in perennial, what happens? This is a constant when we have a constant and continuous supply of water throughout the crop period. Okay, so that we'll called it as perennial. Okay, so how we can supply with the help of that we will see. How we can supply the water. Okay, that we'll see. But before that, I'm going to explain what is inundation. Okay, I'll give you one revision also, no problem. If you have so many things in your mind, I'll give you one proper revision for this. Okay, so for inundation, what we will do, we'll flood the field. Flooded the field with water. Right. Okay, we'll flooded the field to saturate the soil. Okay, to saturate the soil. Okay, in a small intervals or large intervals, depending upon the topography, or we can say depending upon the type of the soil. Okay, so in this we'll flooded. See this. Okay, consider this as the water supply in our home. Okay, so in some cities there will be a 24 hours water supply. And in some city, what is happen? There will be an intermittent supply, like 1 or 2 hour in the morning, 1 or 2 hour in the evening. Okay, so perennial is like 24-hour supply, and inundation is like 1 or 2 hour supply in a morning and in a day. So we'll flood the field in the morning and we'll flood the field in the evening. Okay, or here we are going to flood the field for 2-3 days. Okay, for 2-3 days, then automatic water gets percolated or evaporated, then we'll again flooded the field. So that is inundation, and that will be the pure perennial. Okay, so now I am going to give you a revision for this. So in type of irrigation, I can divide the irrigation into two main categories. that is surface irrigation, and second will be your subsurface irrigation. Okay, so in surface irrigation we have two type of irrigation, flow irrigation and lift irrigation. So when flow irrigation, when we'll use of gravity, okay, or when we have a storage headworks or diversion headworks, or the combination of both storage and diversion. Okay, so what is storage headwork? Nothing but storage headwork is a dam. Okay, when we are diverting the water with the help of dam, when we divert the water of the river to the canal, and these canal will reach to the field with the gravity and will supply the water on the field. So that will be your flow irrigation. Okay, or in case of diversion headwork, we divert the water, we'll divert the water with the help of diversion headwork, same. Okay, only the ways are different. Okay, in dam also we will use dam as a diverting the water and the other uses also, but in diversion headwork our main purpose is to divert the water. Okay, but in the dam our main purpose are different. Okay, diverting a water into a canal is a one of the purpose. Okay, for a construction of dam we have a different uses also. Okay, so this will comes under the flow irrigation, which will mainly when the irrigation is done by the help of gravity, we will call it as flow irrigation. And when my irrigation is done with the help of pumps, means if you have a well in your farm, or if you have any underwater, okay, if you have any underground water, then with the use of pump or tullu pump, or we can use the submerged pump, with that we'll use that water for irrigation also. Okay, so these are the two types of irrigation. So we have a flow irrigation also. We have two types of flow irrigation. One is perennial and another is inundation. What is perennial? In perennial, a constant and continuous supply of water throughout the crop period. When we'll supply the water continuously and constantly with a constant rate throughout the crop period, we'll call it as perennial. Okay, and when we'll supply in an intermittent basis, means after a time interval, after some time interval we'll flood the field, that is called inundation. Depending upon the crop we'll use the type. Now we will focus on subsurface irrigation. So there will be two types of subsurface irrigation. So now we'll see the subsurface irrigation. Okay, please write heading subsurface irrigation. Now we'll see the subsurface irrigation. Okay, so what happens in subsurface irrigation? What is subsurface irrigation? When we supply the water directly to the root of the crop. Okay, please write supplying water directly to the root zone of the crop. Okay, supply of water directly to the root zone of the crop. Okay, so that we called as subsurface irrigation. Okay, so there are some conditions for subsurface irrigation that should be fulfilled. So then we will use subsurface irrigation. Okay, so condition for subsurface irrigation are mainly first is we should have a impervious soil at reasonable depth, okay, like 2-3 meter, okay, or existence of or higher water table is available, or higher water table or existence of higher water table, or I can write existence of higher water table, or existence of higher water table, okay. So this should be the first condition, higher water table, okay. Second will be it should have pervious soil at the root zone of the crop, okay. Have pervious soil, okay. Pervious soil, okay. Why we need impervious soil at a depth of 2-3 meters, okay? Because to hold the water, so that our percolation loss are minimized, okay. Now why we need the pervious soil in the root zone? So that water can uniformly spread in horizontal section, okay. So mainly we want less vertical percolation or less vertical permeability and high horizontal permeability, okay. So write permeable soil, please write permeable soil in the root zone of crop, okay. Next topography. Next is about topography, okay. Topography should be uniform, okay, uniform topography. And what about slope? Slope should be moderate, okay. So uniform topography with moderate slope, okay. The farm should have uniform topography with moderate slope, okay. And last but not least, okay, the water should be a good quality, okay. So we should have a good quality irrigation water, okay, good quality irrigation water, okay. So these conditions should be fulfilled for any subsurface irrigation, okay. If these conditions got fulfilled, and we should have precautions, okay. If these conditions are fulfilled, okay, you should take precautions for accumulation of alkalis and water logging, okay. So if you fulfill all these conditions, and if you take precaution for these two hazards or these two difficulties, then this method is very, very economic, okay. If you will take economic, okay, or efficient, you can write this method is very efficient, low cost, and you should have and low labor cost for land preparation, okay. So these are the advantages of land preparation, okay. So if you fulfill these conditions, if you fulfill these all 4 conditions, and you will take the precaution for accumulation of alkali and water logging, then this method is very efficient, low cost, and with low labor cost for the preparation of land. Okay, clear? I hope this is clear, guys. This is a very good method, but it should you should have these kinds of features in your field. Then only you can apply the subsurface irrigation. So if you want to write these conditions, please write this. Please write this. Okay, please write this. Pause the video and write. Pause the video and write. Okay, if this is not visible, if this is not visible to you guys, if this is not visible, we'll zoom it. I am going to zoom it for you guys. Okay, so I hope now it is visible. Now it will be visible. Okay, so please click a pause button and write the notes. Okay, now we are going to discuss natural subsurface and artificial subsurface irrigation. Now we'll see natural subsurface irrigation. Okay, so what is natural subsurface irrigation? Okay, when water is supplied, okay, when water is supplied with your water table only, okay, by controlling the water table, local water table. Okay, you can write water is supplied by controlling local water table, or availability of, or I can say existence of high water table, or existence of higher water table. Okay, higher water table. Then we will use natural subsurface irrigation. Okay, so how this is possible, sir? How this is possible? So this can be possible by this. Okay, we have a pond nearby to our farm. So this pond will increase the water table of my nearby area. Now, sir, is this possible to do this type of irrigation all over the year? So in some places it is possible, but some places it is not possible. Okay, so if what happens if there will be any deficiency of water? Okay, any deficiency, if any deficiency, for any deficiency, then we'll supply water by artificial ditches. Okay, what we will do, we'll construct the ditches. Okay, ditches on our farm like this. Okay, we'll construct a ditches like this. Okay, we'll construct a ditches like this. Okay, this will be your top view, and if the side view are like this, okay, side views are like this. Okay, side views are like this. Okay, we'll construct a ditches like this. Okay, we'll construct a ditches like this so that we can easily supply the water when it is not possible. When our natural water or existing water table, okay, existing water table will go down, then we'll supply the water artificially by these ditches. Okay, artificial ditches. So depth of these ditches, depth is deep, depth of ditches will vary from 0.3 to 1 meter. Okay, and its width its width of ditches are like 0.25 to 0.5 meter. Okay, and these are spaced, okay, spacing of 15 to 100 meter, okay, depending on topography and type of soil okay. So these are your natural subsurface irrigation. So we'll take a quick revision. What happens in natural subsurface irrigation? So in this, we'll supply the water with a if the local water table, or by controlling the local water table, or if existence of higher water table is there, we can easily use the natural subsurface irrigation. But if any deficiency will take place, we'll supply water by artificial ditches, by constructing artificial ditches. So these ditches will have a depth of 0.3 to 1 meter, having width of 0.25 to 0.5 meter, okay, or you can write 25 centimeter to 50 centimeter, spacing of 15 to 100 meter depending upon the topography and the type of soil. If soil is more permeable, then we will increase the spacing. If soil is less permeable, we will decrease the spacing, okay, depending upon your topography and type of soil. Next is, so this will be the diagram for your natural subsurface irrigation. Next we will see the artificial subsurface irrigation. Please write artificial, artificial subsurface irrigation. Now we'll see, second is your artificial, okay, artificial subsurface irrigation, okay. So what happens in this artificial subsurface irrigation? We will supply the water is supplied by a network of water, please write, water is supplied by a network of buried perforated pipes, okay. Water is supplied by a network of buried perforated pipes, okay. Like this, you can see, we'll bury the perforated pipes inside the soil, so that water will come from this perforation. Water will come when we'll supply the water with pressure, okay. Here we are supplying the water with pressure, okay. Supply water with pressure, okay. Supply water with pressure, okay. That's when then only water will enter in the pipe and move out from these perforates and move out from these holes, okay. Then only water will move out from these holes, okay, if we will supply the water from the pressure, okay, with the pressure. Now for a good artificial subsurface irrigation, okay, for good irrigation, okay, or for efficient irrigation, what happens? Horizontal permeability. If my soil is having high horizontal permeability, okay, it should have high horizontal permeability and low vertical permeability, okay. what happens if I am having a high horizontal permeability, then water will uniformly distributed, okay, uniformly distributed, and if I am having a low vertical permeability, then minimum loss of I can say, if the water is having minimum or low vertical permeability, then minimum loss due to percolation, okay. So this is about your artificial subsurface irrigation. Now sir, what about the pipes? Okay, so pipe are buried at the depth of, okay, so these pipes, okay, if you want to write these things, you can pause the video and write the things, okay. So the depth should be these depth should be 0.3 meter to 0.4 meter, okay. This depth should be 0.3 to 0.4 meter with spacing should be 0.4 meter to 0.5 meter, okay. So why this depth will be 0.3 to 0.4 meter to avoid avoiding any disturbance, so that okay, or I can write this distance. Why I am taking 0.3 to 0.4 meter? Why I am taking? So that there will be no disturbance in cultivation process, okay. That's why I am burying the pipe into 0.3 to 0.4 meter. Or why I am having a spacing of 0.4 to 0.5 meter? Because so that water gets uniformly distributed, okay, so that water gets uniformly distributed, okay, please write these things. If you want to write, you can write this. If you want to draw the diagram, you can draw the diagram, okay. So these are about the type of irrigations, okay. So we'll study in the type of irrigation that okay. So we already studied about the type of irrigation. So we have two type of irrigation, surface irrigation and subsurface irrigation. In surface irrigation, we have two types, flow and lift. Flow is when we'll supply the water by the gravity, that we'll call it as flow irrigation. When we'll supply it by pump, then we'll call it as a lift irrigation, okay. So we'll use flow irrigation where water is available at the high head, and when the water is available at the low head, we'll use lift irrigation, okay. So flow can be divided into two parts, perennial and inundation. What is perennial? When we'll continuously and constantly supplying the water, that is called perennial. And if we'll supply the water in an intermediate time interval, that is called inundation, okay. So what will be the source for lift irrigation? That can be a well or any groundwater existence. What will be the source of the flow irrigation? So any river, so by storage headworks or by diversion headworks, or with by both the combination of storage and diversion headwork, we can supply the water by flow irrigation, okay. So what will be the storage headwork? Dam will be a storage headwork, okay. And diversion headworks are weir and barrages, that we will study in the detail in our next chapters, okay. Now we will focus on subsurface irrigation. So for subsurface irrigation, you should, what will be the subsurface irrigation? When you supply the water directly to the root zone of the crop, okay, directly to the root zone of the crop. So what are the conditions? So the conditions are soil should be impervious at the depth of 2-3 meter, okay. Otherwise what happens? Otherwise I will lost my water due to percolation, okay. Next is my soil should be permeable in the root zone of the crop so that water can be uniformly distributed. Next, topography should be uniform and slope will be moderate, okay, so that water will not accumulate at one side of the field. Next, so the underwater should not be, groundwater should not be contaminated. It should be a good quality irrigation water. Next, so after these conditions, you should take a precaution for accumulation of alkali and water logging. So sir, if accumulation of alkali will be more, then it will affect our soil fertility, okay. So if we cannot take a precaution for these conditions, we will switch from subsurface to surface irrigation, okay, because this is very hazardous for our soil. So if these all conditions are fulfilled, then this method will be the best method, efficient method, low cost method, and with low labor land preparation, we can use this method, okay. Now next will be your natural subsurface. So when we will use natural subsurface? When we have a locally, by controlling locally water table, or if we have existence of high water table, we can use natural, which is very low cost, because in artificial what happens? We are burying the perforated pipe, which will cost so much, okay. So natural is low cost as compared to artificial, okay. So what happens? Because this is natural, so the supply will not be continuous or constant. So if there any deficiency will come, then we'll construct a small ditches in our farm, which will have a depth of 0.3 to 1 meter, width of 0.25 to 0.5 meter, and spacing of 15 to 100 meter, depending upon the topography and type of the soil, okay. If soil is permeable, then we'll increase the spacing. If soil is less permeable, we'll decrease the spacing, okay. And last, this is about your natural subsurface irrigation. And last is our artificial subsurface irrigation. So in this, we'll supply the water with the help of networks of pipe. These pipes are perforated so that water will come from these pipes easily, okay. So next, for we'll supplying the water with pressure. If we'll not supply the water with the pressure, then there will be accumulation of water in the pipe, and water will not come from that perforated section, okay. So for good irrigation, the soil, for good artificial subsurface irrigation, soil should have horizontal permeability, high horizontal permeability. Why high horizontal permeability? So that my water will be distributed uniformly, but it should have, soil should have low vertical permeability, so that we can minimize the percolation loss, okay. Now what about the measurements? So the pipe will be buried under 0.3 meter to 4 meter. Why I am burying at these depths? So that no disturbance will be happen in our cultivation process, and with the spacing of 0.5 to 4 to 5 meter. Why I am giving this much space? So that water can be easily distributed, uniformly distributed, okay. So this is about your type of irrigation. Now we will move to the method of irrigation.